Hello, and thank you for joining us today for Frost & Sullivan's latest webinar from our Tech Vision practice. Today's event is titled Top 50 Disruptive Technologies and Innovations You Need to Know About. My name is Anna, and I oversee Frost & Sullivan's Growth, Innovation, and Leadership briefings. Before we begin, I'd like to go over a few quick notes. We encourage you to ask questions throughout the presentation, and you can do that by clicking on the Ask a Question button. Also, under the Attachments button, we have a short video and a link to the Tech Vision website. You can also safely share this briefing at any time by clicking on the Share button. On today's presentation, we will have some detailed slides, so there's a full screen feature available to you at the bottom right-hand corner of the screen. Our presenter today is Rajiv Kumar, Senior Partner here at Frost & Sullivan. He's a global head of Frost & Sullivan's Tech Vision business unit since 2001. He has built his career on a foundation of 2 decades of experience directing strategy, consulting, and research businesses in the emerging technology fields. He has managed several research practices like chemicals and materials, sensors and instrumentation, building technologies, security, and others, giving him diverse industry knowledge. Now, connecting his broad vertical business expertise with the horizontal technology focus, Rajiv is on emerging and disruptive technologies, innovations, and technology convergence. The Tech Vision Group concentrates on identification and convergence of emerging technologies, leading to new products, services, and revenue models of the future. With that, I would now like to hand the presentation over to Rajiv. Please begin.
Thank you, Anna. Are you able to hear me? I assume so. Well, good morning, ladies and gentlemen, and welcome to this briefing by Tech Vision. Thank you really for your time, and I'm excited and thrilled to have this opportunity to talk about some really interesting work we are doing in the field of emerging technologies, innovations, and perhaps more interestingly, technology convergence. About 8 years ago, the Tech Vision team launched a unique research initiative called the Top 50 Emerging Technologies and Convergence Opportunities. And it had 2 primary objectives. The first was to apply a specific methodology to a very large base of technologies and innovations to generate an annual list of top 50 technologies that are likely to make a significant impact in our lives in the near term, like in the next 1 to 2 years time frame. And the second objective was to look for possible technology convergence scenarios where 2 or more of these top 50 technologies and beyond are likely to come together to create an innovative or disruptive market for new products, services, solutions, or business models. Since this unique research effort and thought leadership resulted in several unprecedented outcomes, we started calling this initiative as the future of the future. Now, before I get deep into my slide deck and show you some of the information that we have ready for you today, I want to begin by giving you a quick background about the kind and scope of work we do and define the context of today's presentation. So the Tech Vision Group is the technology, IP, innovation, and convergence-focused research and consulting practice of Frost & Sullivan. Our global technology analysts are based in 6 continents and are constantly researching organizations that are involved in various types of R&D, engineering, technology, and product development activities, be it academic institutions, science and tech-focused government agencies, national labs, and certainly the private sector, ranging from startups to the largest of large companies around the world, which spend millions of dollars on innovation and technology development each year. We organized the universe of technologies into 9 different technology clusters, such as the ICT, or sensors and instrumentation, chemicals and advanced materials, microelectronics, medical devices and imaging, and so on. you see these 9 clusters represented by 9 globes. We believe that more than 90% of all technologies and innovations can be mapped in these 9 clusters, giving us a very comprehensive view of the entire world of technology development. As you could imagine, these technology clusters cut across several verticals, meaning a technology developed in one cluster usually has applications across several industries. For instance, advanced material technologies used in the automotive, aerospace, textile, packaging, infrastructure, and many other industries. Similarly, AI technology, which is literally in the news every day, is being horizontally applied to manufacturing, education, financial, agriculture, mobility, and several other verticals. So in a nutshell, our organic and continuous work in researching hundreds of interesting technologies across multiple organizations, clusters, industries, and regions helps us in identifying the top 50 hottest technologies, as well as numerous potential technology convergence scenarios. This, we believe, is of course very interesting, and it's valuable for business and technology leaders, government policymakers, as well as end users. We've been doing this annual exercise of choosing the top 50 technologies for the last 8 years. We get together around the month of March, the entire team of TechVision, and we pull together our list of top 50. There is no doubt that technologies have rapidly evolved in this period of time, and we have witnessed a lot of dynamism in the global R&D landscape. The rate of innovation and launch of new technologies and ideas is getting faster every year. And literally every month, we come across intriguing products and business models globally. Every organization, regardless of their size or business, is keenly focused on innovation, and it is probably the most popular word in today's corporate strategy. We are living in an era of X-Tech. One can add the word tech to pretty much any industry, and it is easy to see the impact of emerging and disruptive technologies in that specific industry. For example, fintech is for financial industry, edtech, education industry, agtech for the agriculture industry, and so on. In other words, whether innovation is for products or services or operations, processes, business models, it seems to be always driven by emerging technologies. So while everyone is innovating and focused on that, and everyone is aware of broadly the same set of emerging technologies, the key to innovation is in knowing what the customers would want in the future, in some cases even before they do, and acting on that intelligence, even if it seems too futuristic or impractical at the moment. The companies that take that leap of faith seem to be the ones making the largest gains today. Now, if you look around, you'll easily find several examples of disruptive innovations and new business models based on emerging technologies and their convergence. For instance, drones are no longer just strategic weapons of war. They are being utilized for peaceful security monitoring, farming, photography, gaming, weather mapping, and all sorts of practical applications. And soon enough for delivery and logistics business models for all sorts of packages, whether it's books and food, medicine, clean water, electronics, and perhaps even as mobility solutions for people in the future. Similarly, one of my favorites, autonomous cars, they're fast becoming a reality. This is perhaps the most interesting and most talked about field of innovation in the world today. Here's an interesting fact. 3 years ago, only 3 car companies had approvals to test self-driving cars in California. As of April 1st this year, that number has mushroomed to 52. And interestingly, of these 52 permit holders, there are only about a dozen companies that are traditional car manufacturing companies. The remaining are all sorts of electronics, AI, and software companies like Samsung Electronics and Intel and Apple, Google, Baidu, and several others. Autonomous driving technology opens up a potential for a whole range of disruptions in the design, manufacturing, sales, and marketing of such cars. We predict that over 500,000 autonomous cars are likely to be added every year globally by the year 2025. And 1 in every 4 cars will be self-driving by the year 2030. And that's a conservative estimate. Now, beyond these, there are several other examples. I won't spend time on explaining each and every one of these. But the examples of disruptive innovations like 3D printing, the Amazon Go store in Seattle, AR and VR combinations in various applications, and several examples of collaborative consumption business models like Uber and Airbnb, and pay-for-use versus pay-for-possession, circular economy business models. One of the new ones is LAS, Light as a Service, by Philips and some other vendors. In a nutshell, we are living in a truly fascinating world at an intriguing time of our lives, and it is going to get a lot more interesting and exciting in the coming years and decades as scientists figure out metamaterials and perhaps how to modulate gravity on demand. It's a matter of 15, 20 years. This technology is all around us and all pervasive, and it's literally inescapable today. So we took this reality of a fast-changing, innovation-driven future world and applied it to our continuous work on researching emerging technologies in order to predict some new innovations and serendipitous convergence. As a result, we created a framework that you see on your screen now for combining different core elements of innovation to predict new disruptive innovations and potential scenarios. We call it the innovation engine, which looks like and works like a kaleidoscope. So let me get into this a little bit. There are 5 rings in this model, and each ring represents a unique perspective. And when combined with the other 4, it creates a new roadmap or convergence possibility. The outermost ring represents the 9 technology clusters I talked about a little earlier, wherein we are constantly analyzing hundreds of technologies and developments in each area as part of our ongoing research. The second ring represents megatrends, which are directly or indirectly influencing our lifestyles and global businesses every day. Although trends are constantly evolving, it is the technology capability that sustains key trends and gives rise to new ones, resulting in an acceleration of certain trends and suppression of others. So if you look at the interrelationships of technologies and broad megatrends to find what technologies are driving which megatrends, that's certainly useful. The third ring represents new business models like freemium, which is common in the software business, co-creation, sharing, crowdsourcing, and several others. New business models are generally created from a desire to bring together technology capability and ride on the ever-evolving trends to deliver business innovation. Interestingly, all the new business models have been only possible after deep penetration of the internet connectivity, the speed at which data is transmitted and possible to transmit today through fiber optics as well as wirelessly using 4G and soon 5G, and wide-scale adoption of handheld personalized devices. And these business models are driving new growth opportunities that will shape the industries and markets of tomorrow. We also look from a viewpoint of key vertical industries to see potential applications and adoption rates of technologies. Market participants in different sectors adopt technologies and convert them into products or services. So their influence on technology adoption and monetization is super, super critical. And then the final innermost ring, that represents all sorts of organizations that are driving technology developments and pushing for their adoption. These are innovation ecosystem drivers and include various corporate and academic technology labs, investment firms, standards and IP bodies, end users, government agencies, etc. So if you visualize this image as 5 sets of independent variables that can move independently, just like a kaleidoscope, this model can generate hundreds of potential convergence scenarios and innovative products and services. This framework forms the basis of our thinking and helps us in guiding companies by tracking technologies and creating unprecedented business scenarios by fusing technologies, trends, new business models, industries, and technology ecosystem drivers. Believe me, it gives rise to some of the most interesting business models and solutions that one can think of. Now, moving on, as part one, I mentioned about two objectives of our exercise. The part one, or the first objective of the Tech Vision initiative, is to select the top 50 technologies impacting the world in the next couple of years. But how do we go from literally hundreds of technologies spread across 9 clusters to just 50? Well, we use a specific methodology. It's almost like a stress test by applying 8 weighted criteria to each of the technology candidates. For instance, we look at the IP activity in the last 3 years and counted the number of patents published globally for each of the 900 technologies. Similarly, we tracked public and private funding in the last 2 years for each of the technologies. Cumulative market potential in the next 5 years, again, for each technology. Number of megatrends impacted, number of industries that would adopt each technology, number of countries and regions that would be impacted, and so on and so forth. We used a weighted model to rate each technology on each of these criteria and created an innovation index score, and that helped us to pick the highest rated technologies. This methodology has allowed us to identify several technologies early on, which have gone on to become giants today. For instance, back in 2014, we identified graphene as a top 50 technology, which today is a very large growth opportunity across multiple sectors. Similarly, we identified OLEDs, super hydrophobic coatings, microbiomics, and other technologies in previous versions of top 50 research, which have now become technologies of large-scale adoption and potential. So our confidence in this method and our list is very, very high. And who knows, the selections we made this year may end up being some of the brightest market opportunities in a year or two, leading to creation of some new unicorns. Our latest top 50 technologies research is available on an interactive platform, and it provides in-depth intelligence on each of the top 50 technologies on each of these criteria. It's a very comprehensive piece of work. The attachments tab on your monitor has more details about how to access the research. So, if you're interested in knowing about the 50, here is a map that shows everything. The net result of our comprehensive year-long research and selection process were these 50 technologies spread across 9 clusters. The clusters are highlighted in blue. There are 9 of those. And each has between 4 to 7 individual technologies and innovations which made it to the top 50 this year. Now, some areas were more obvious, didn't surprise us than others. So technologies like 5G and blockchain, LiDAR sensors, which are used in autonomous cars, collaborative robots, advanced batteries, these seem to us as more obvious to make the list. While there are many others that were new and interesting. E-glass, also known as smart glass or intelligent glass, AI chip, myoelectric prosthetics, haptic reality, which takes us beyond AR and VR zones. These were some of the new ones. A few things that are noteworthy here on this chart. We started with a base of over 900 technologies in the first round this year. We eventually rated over 400 technologies using a proprietary methodology I explained in the previous slide. 13 technologies repeated from previous year, and that is generally the trend we have seen over the last 7 years. About 25% of technologies within the set of 50 kind of stay hot and move from one year to the next. Some of the repeats this year, for example, are self-healing materials, as they have several applications in the automotive, aerospace, packaging, electronics, construction types of sectors. 5G is a repeat, which has raised excitement in the IT, mobility, and healthcare sectors. Others include biosensors, metal 3D printing, cobots, etc. On an average, health and wellness cluster technologies got the highest innovation index score, followed by ICT technologies, and then energy and utilities, and environment and sustainability. We got some very promising signals from this kind of universe of 50 technologies. Consider this. The total market potential of these 50 technologies is nearly $3 trillion over the next 5 years. over $100 billion was invested in R&D of these technologies in the last 2 years. And there were over 175,000 patents that were granted, published in these 50 areas in the last 3 years. So each technology area has its own ecosystem or network of scientists, developers, funding sources, evangelists, standards organizations, associations, you name it, patent holders, and so on and so forth. And it's really exciting. There are amazing groundbreaking developments taking place in each area, and that is very valuable. However, what is even more powerful, in my opinion, is the white space in between these technologies, where a lot of collaboration and convergence is happening or could potentially happen in the near future. The random but practical combination of multiple technologies to create a valuable solution is what will be a significant game-changer trend in the future. I'll show you and I'll tell you more about this in just a few minutes. Now, I wish I had time to go over each of these 50 technologies and explain what's happening in the background. That certainly will take a lot of time. But in the interest of time, I will highlight 3 technologies from different clusters and talk about some others later in the presentation. So the first one I have chosen is cognitive security. It's part of the ICT cluster, and it's actually not a surprise given the spate of cybersecurity attacks and threats we learn about almost every week. The World Economic Forum has listed cybercrime as the #1 global risk for businesses in 2018. 98% of companies operating globally experienced malware-based threats last year. More than 200,000 people in 150 countries were affected globally by the WannaCry ransomware attacks in 2017, and over 1 million computers still remain vulnerable. A cognitive security system outthinks and outpaces threats with security systems that can understand, reason, and learn from previous experiences. Cognitive security refers to the use of cognitive technologies such as AI, machine learning, and natural language processing to make sense of security data that has previously been unanalyzed by an organization's defenses, enabling security analysts to gain new insights and respond to threats with greater confidence at scale and speed. Cognitive systems have the ability to recognize natural language and make connections between data points that a security analyst, a human, may have never considered. Social platforms, including Facebook, now use cognitive systems to flag posts from people thinking about harming themselves or spreading hate messages. Cognitive security is typically used, or it's widely used, for user behavior analytics application, identity and access management application, and certainly for data security applications. For user behavior analytics application, cognitive security helps eradicate insider attacks and user-generated vulnerability. In identity and access management application, cognitive security leverages in-depth analysis of risk information databases to ensure zero unauthorized intrusions. Several companies are spearheading developments in this area. For example, Spark Cognition's approach to endpoint protection is to integrate machine learning and deep learning technologies. Their Deep Armor analyzes the DNA of unknown files by breaking them into small components to check for malicious nature. Deep NLP's automated decision-making capability classifies the documents in a similar way as humans do. Blue Vector is another key player in this area. Their threat detection platform leverages machine learning technology to detect, analyze, and classify malware. The patented architecture allows the platform to run several detection engines in parallel, resulting in 99.1% and beyond detection accuracy. The platform is designed to work on all IPv6 and IoT-rich environments. And then RSA security and behavioral analytics solution uses statistical and machine learning techniques that speed up cyber threat detection and help the security analyst to respond to cyber and threats in the real time. The next technology to quickly talk about is advanced batteries. It's a very interesting area. Metal ion and metal air batteries are upcoming alternatives for lithium ion. The 2-year period starting this year will be very important for the researchers and commercial stakeholders to help the end user realize the importance of battery technologies other than lithium ion. This period of 2 years will also be crucial for determining the future of these post-lithium ion batteries. Some of the important post-lithium ion solutions include lithium air batteries, which are considered as the next big thing of rechargeable batteries. Although their technology readiness level is still low, their theoretical specific density values are approximately 16 times more than that of lithium-ion batteries. This means that they present the opportunity to increase the operational time by a factor of as much as 2. In terms of solutions with most promising commercialization capabilities, we believe that sodium-ion and lithium-sulfur batteries have better chances of adoption. These two technologies are better poised to reach the necessary technical maturity for commercialization. The innovator ecosystem for advanced batteries involves stakeholders across the value chain, from raw material producers to battery packagers across regions. Even though startups, predominantly university spin-offs and research institutes, are dominant in the U.S., growth in Europe is also very promising. In Europe, announcements regarding battery megafactories are expected soon. It is important to note that APAC is still a force to reckon with, given the number of megafactories already present in that region. Some of the key areas of R&D focus are developing suitable materials, which are very important in making the batteries charge much faster, providing better energy and power density capabilities, and also in making them safer. Developments in materials used in electrodes, electrolytes, and phase of the electrolytes have led to promising solutions with improved safety and storage capacity. For example, Anyweight in the U.S. Has developed a high energy density battery which uses anodes that are based on silicon, which offers lithium-ion cells up to 50% higher capacity than conventional graphite cells. The next technology to talk about briefly is the microbiomics or microbiome technologies, and they are poised to transform the global healthcare landscape. Exponential rise in microbial research and growing industry interest will facilitate groundbreaking microbiome-based innovations across pharma, personal care, and food sectors, which help restore natural microbial balance in humans, thereby improving overall health and wellness. Emerging innovators such as Vedanta and Ubiome are looking to develop microbiome-based therapies for gastrointestinal diseases. Another company, S Biomedics, is looking at the skincare space for introduction of revolutionary microbiome-based platforms, and Azitra may eventually lead the future of genetic engineering platforms for microbiome-based solutions. The U.S. is likely to lead the therapeutic applications across the entire landscape of microbiomics, while Europe, we believe, will emerge as one of the leading players for innovative and groundbreaking applications in personal care and food and beverage products. Companies such as Chris Hansen will likely lead the probiotic landscape by developing robust probiotic strains with scientifically proven health benefits, whereas some companies like Azitra I mentioned are likely to develop novel genetically tailored microbial platforms for disease management. Brain health will be the focus area for microbial technologies in the future. For instance, Calliope, a very innovative startup, is focusing on using microbiome platforms for gut-brain axis application. Okay, moving forward, while the top 50 technologies I talked about, I showed you, and I talked about 3 in a little bit of detail, they represent the near-term hot technologies that have a high technology readiness level. We also created a unique list of 18 futuristic technologies with low technology readiness level scores, meaning that these are at least 5 to 7 years away from commercialization. These future 18 technologies are still being researched and developed in the labs around the world, and they are great potential candidates to be part of future top 50 lists in a few years. For instance, quantum computing, based on principles of photonics, will radically increase the speed of computation. It is still in experimental stage and likely to start making inroads in about 5 years. Rare earth recovery, that's part of the environment and sustainability cluster, is becoming a bigger need by every passing year. All sorts of modern technology devices, ranging from consumer electronics to cars to satellites to defense systems, they rely on rare earth elements, and their availability is fairly limited and certainly getting more scarce. As a result, there is significant research happening around the world to recover rare earth elements from various sources such as coal and coal byproducts. Zero friction coatings are a subset of low friction coatings that are strong, super slippery, anti-stick, and omniphobic, not just hydro and dirt and dust phobic, but omniphobic. Key applications for super hydrophobic coatings and for zero friction coatings certainly are in the automotive, packaging, medical devices, and marine industries. Printed organs, they kind of sound like an obvious evolution for the next stage as genetic engineering and 3D printing solutions will likely converge. It made it into our list of future 18. And Power to X, which is in the energy and utility space, they're a set of conversion technologies that allow using power beyond the electricity sector in other sectors such as transportation or chemicals and materials. The X can refer to anything like power to chemicals, power to fuel, power to heat, power to liquid, and other similar conversions. There are many other exciting technologies on the horizon beyond these that may become mainstream in the next 5 to 7 years, but we are absolutely keeping our eye and pulse on the development of these technologies and include them in our top 50 research going forward. Now, being the analysts that we are at the core, we certainly like to play with data. We look at a very large set of data points and made several trend charts and 2x2 matrices and scatter graphs. I just picked up 3 to quickly showcase in the briefing today. This chart is a 4-dimensional chart which shows each of the top 50 technologies plotted on revenue potential over the next 5 years and number of patents granted globally in the past 3 years. The size of the bubble represents the innovation index score, and the color of the bubble represents the number of sectors likely to adopt that technology. Just a quick reminder, each of these 50 technologies are already the best of the best. So everything you see here packs a very large business potential. But what this chart does is provide a visualization of how these technologies stack against each other and their level of impact across industries and their market potential over the next 5 years. Let me highlight a couple of technologies as we go along here, just that you see as circled. Hyperimaging analytics, shown as HA, is gaining prominence beyond healthcare and surveillance applications. They're getting into food, into agriculture, into mineralogy, and environmental monitoring. Future developments are likely to create opportunities enabling armed forces to detect chemicals and biological threats, and in assisting clinical healthcare staff in performing non-invasive surgeries. Small data, shown as SD. With the advent of Internet of Things and connected ecosystems, data is growing rapidly and is becoming an integral part of the evolving IT infrastructure. The latest trend in the data analytics space is to uncover granular details about the business impact from every data set connected to the enterprise network. The next generation of data analytics will be able to consolidate these small data clusters to improve efficiency in big data analytics process. This next graph is what we call as a technology attractiveness matrix. This plots number of patents and funding levels. Higher the number of patents and higher funding indicates that technology is ripe for commercialization. Let me pick a couple of examples here as well. BioBetters that you see on the top right corner. These are basically recombinant protein drugs that are similar to the existing biopharmaceutical, but they are not really identical. Rather, they are improved over the original drug. BioBetters build on the success of existing approved biologics, but are considered less of a commercial risk than developing a brand new class of biologics. Biobetters are not entirely new drugs, and they aren't generic versions of the drugs either. They are suitably poised to replace biologics that are likely to go off patent list in the short-term future. They will very likely lead transformative changes in the field of medicine. The rising popularity of blockchain, that's the other circle technology here shown as BC, is due to its ability to increase trust by combining cryptography with decentralization. Companies are building their own blockchains across industry sectors such as fintech, energy, transport and logistics, insurance. Government is doing it by providing a simple and secure mode of transactions, both financial and non-financial transactions, thereby simplifying the movement of money, goods, and data worldwide. And finally, this third chart, this is a 2x2 matrix called the market attractiveness matrix, wherein we have cross-plotted market potential cumulative over the next 5 years and the number of sectors. We counted up to 23 different sectors that are impacted by each of these top 50 technologies. Deep learning, shown here with DL, enables intelligent automation of workflows and business processes, which are driving higher level of efficiencies and transforming the fundamental way of doing business in almost every sector globally. The future may soon be one where humans and computers move from being separate entities to becoming a single cognitive unit. Nanohybrids, shown as NH, with its ability to enhance performance characteristics and provide added functionality to an end product. Nanohybrids are poised to impact countless applications across all major industries. The wide portfolio of materials, coatings, and nanoparticles helps in addressing application-specific requirements of industrial or consumer sectors. Okay, I talked about two core objectives of our exercise. One is obviously to select the top 50 from a very large list using a methodology. The second core objective behind TechVision's annual top 50 emerging technologies research is the identification of potential convergence scenarios of multiple technologies. We call this concept as waves of innovation. Each technology creates waves of adoption which first impacts its home industry, and then it grows to impact parallel sectors. It gets very interesting when technologies start to interact with each other and create unique products and services. For instance, in this example, metal 3D printing, deep learning and AI, and sensor fusion technologies could come together to create controlled 3D printing for predictive maintenance. The application is in high-end industrial manufacturing setups where sensors would provide critical data to facilitate predictive data analysis using AI protocols on component and machine failure. This information would facilitate production of customized components using metal 3D printing before the parts actually fail. This will lead to reduced downtimes and improved productivity. On the other end, metal 3D printing and ultra-high strength metals and lightweight materials are already converging, leading to applications in the automotive, aerospace, and defense industries. So you get the idea of how technologies could potentially come together and create something new and different and replace an existing solution. So the TechVision team developed dozens of such convergence scenarios every year. Again, this year we had over 50 similar examples that we developed. Let me do a quick showcase of some other interesting examples that we came up with. This is a scenario of personalized error-free medicine. This is basically an automated feedback-initiated therapeutic or a diagnostic system. We call that as a theranostic system based on wearable sensors and drug delivery systems. The concept of a self-monitoring, self-administering drug system appeals at multiple levels. The system would ideally measure various indicators of diseases in the bloodstream and administer drugs when the recorded value is below or above acceptable thresholds. This would remove errors in under or overdosing and ensure medication compliance. A few relevant technologies could be combined to make this work. Wearable devices equipped with AI chips can be used for personal wellness and life logging applications. Similarly, biosensors can test blood for biomarkers to give indication of drugs and supplements needed by the patient. Self-healing materials could be integrated for repair of devices and components, and targeted drug delivery technologies could be used for supply of encapsulated insulin and other chronic medications. AI and NLI could be used for dynamic patient interaction, making payments, scanning, and even for gamification. The main challenge of an automated therapeutic system or this theranostic system is obviously the accurate sensing of biomarkers and other indicators of diseases. The sensitivity and accuracy of the sensor system has to be of clinical grade. Another challenge would be to effectively integrate sensors, electronics into a single wearable unit, preferably one that is discrete and does not require too much of patient input or risk of tampering. But having said that, there are huge opportunities in this technology convergence scenario. Biosensors are an area of great research interest currently, with companies such as Google, Siemens, iSense, and others working on implantable and embedded sensors that can measure bioelectrical and biochemical outputs. Funding levels for biosensors is attractive, as also is the competitive landscape. This is an area of significant R&D activity. The success of first and second generation wearable devices that are mostly available in the form of wristbands today is encouraging developers to further miniaturize the devices and pack them with more powerful sensor platforms. This next example may bring a smile to your face. MAGA could stand for different things. For us, it means make agriculture great again. Since the early 90s, the importance of water as a precious resource has been recognized, along with the political implications of water sharing and scarcity. Only 3% of the world's water is fresh and can be used for drinking, sanitation, and agricultural applications. Of this 3%, only a fraction is easily accessible. On the other hand, many large cities around the world are located on the shores of seas and oceans, providing salt water that can technically be reused for farming and drinking. At the same time, indiscriminate farming and unsustainable agricultural practices have put a lot of pressure on arable lands, gradually lowering their yield and productivity. All this brings the focus to developing sustainable farming practices and at ways to improve crop yield and output. We analyze this challenge from a number of different angles and believe that convergence of technologies can offer a possible interesting solution. This convergence scenario is well suited and is of great importance to geographies where the access to fresh water and poor land use has been affecting agriculture for decades. We believe that mobile desalination plants can help convert large volumes of salt water into usable water for agriculture. Advanced battery systems using next-gen lithium-ion batteries and beyond can help power these systems even in areas that are remote or not readily connected to the grid power, as is the case with most struggling agricultural areas. We can use microbiomics in this combination as well. Colonies of bacteria present in the soil help plants absorb water and nutrients, improve immunity against diseases, reduce yield, and withstand climate experiences and extremes. Identifying and favorably supporting these microbes can help improve agricultural outcomes. In fact, pilot projects are already underway to examine the impact and performance of microbial-coated seeds. And then finally, advanced encapsulation technologies can help in targeted delivery of nutrients to the plants, preventing wash-off. Further, encapsulation can help in sustained release of pesticides and fertilizers and increase bioavailability of nutrients. This could truly be the next generation of advanced precision agriculture. And then finally, this last example, this is an example of smart energy economy or transactive energy, which is an energy e-commerce model based on a connected network. Basically, energy is generated at the site of consumption, and energy consumers practically become energy generators as well. Decentralized energy resources will be interconnected to coordinate supply and demand. By bringing different energy and information technologies together, a smarter, self-sustaining neighborhood could be created, which promotes localized energy production and management. These technologies will enable a smart grid that can replace the conventional utility smart grid or supply grid. Sensor fusion technology, along with deep learning and AI solutions, would provide guidance on balancing the local demand and supply of energies during peak hours. And blockchain technology would provide the trust and security in all individual transactions. The opportunity here is in coupling on-site renewable energy sources such as solar and wind and waste to energy with efficient energy storage systems such as advanced lithium batteries. Also, there is opportunity in optimizing localized renewable energy generation. Feed-in tariffs allow consumers to earn income from selling excess energy generated at their location, and it also allows reform of public utility regulations and restructuring of utility operations. Well, I've used this cartoon before. I'd like to end my presentation with this again, which shows that you never know who is looking for what kind of help, but together a solution can be found. This was just a small sampling of innovative convergence scenarios that we have developed internally. And so many other combinations are possible. It obviously depends on specific industries, applications, and more importantly, on innovative and collaborative minds to come together to create something unique and valuable. You can take advantage of this perspective by making extraordinary growth partnerships and leveraging points of convergence. Look around your organization within, whether it's small or large. Look around your industry, whether it's small or large, and certainly across industries. And even at your competitors, and you might find several potential collaboration partners willing to leverage points of convergence to co-create a very interesting future. This latest analysis of the top 50 emerging technologies is now available along with top 10 convergence scenarios research. And of course, we work directly with clients as well to develop custom solutions based on their specific situations. Please feel free to write to me directly or through the contact channels Anna will provide shortly if you're interested in accessing these research findings and insights or would like to discuss any part of it. Thank you so much for your time. And Anna, back to you.
Thank you, Rajiv. Now, at this time, I'd like to open up the floor for a question and answer session. We have several minutes here, so we'll try to get to as many questions as possible. If not, we will take those offline. So our first question here, in this selection of 50 technologies, an annual exercise, is this an annual exercise? And if so, do some technologies repeat over the years, or are they always unique?
The 50, it's an annual exercise, like I had mentioned earlier. We go through this very detailed process. In a year, if I may take a step back, in a year we look at approximately 3,000 different technologies, and then we get together in the month of March, all the technology analysts, and we look at these technologies together, put it through our methodology, and come up with the top 50. So yes, it's an annual exercise. The top 50, like I mentioned, are on a short-term future in the sense they're hot for the next 1 to 2 years time frame. We expect them to be commercialized in the next 1 to 2 years. And then the future 18, which is also an annual exercise, is more of a 5 to 7 year kind of a time frame. And in terms of repeats, about 25% of technologies are repeating on a yearly basis, not the same 25%, of course, but we look at about 13 to 14 out of the 50 that kind of go back into the top 50 selection for the next year. So yeah, so that's the kind of repeat rate that we see on an annual basis.
Thank you. And another question here, are you able to share the slides?
Yes, I think we should be able to share the slides. Perhaps not all the slides that I showed today, but certainly some parts of it. Some of this is for our paying customers only, but we'll be able to pull certain slides out of this deck and be able to share that.
Very well, very well. Our next question, you mentioned earlier the enablement provided by the Internet. Looking back for a second, machine-to-machine sensors are over 50 years old. What do the sensors of the future look like?
Interesting question. I think sensors, perhaps from a technology point of view, would not change much. Perhaps they'll become smaller and faster, but the larger scenario we see is the sensor fusion technologies, where a single sensor will be able to pick up on multiple parameters, and then networking of sensors that would create a scenario where you can do a lot more networking of devices. You can speed up the transmission of data between the sensors and get that intelligence out of the system. So we'll see that kind of a change rather than a change in the nature of the sensors themselves.
And regarding the success rate, what has been the success rate of your top 50 selections in the past years?
Actually, very good. I think I talked a little bit about it right at the beginning of the slide deck. We actually have been fortunate, perhaps, to lay our sights on certain technologies over the last several years that have gone on to become very big. I can name a few. For example, OLED technology, starting from the 80s as a test product, and now in the 21st century, every year, OLED technology is still seeing advancements as months go by. Various industry giants like LG, Samsung, GE, Toshiba, and many others have invested heavily on OLED production facilities very early on. We focus on emerging technologies, and we identified OLED to disrupt the display and lighting market several years ago. Advancements in OLED have been captured as early as 1998 in some of our technology alerts, some of the reports that we do. The technology has been featured in our top 50 technology selections since 2013. When the world was considering LED to be the future technology for display and lighting applications, TechVision identified the efforts and initiatives of research institutes and industry participants. We focused on developing a technology that is future-proof. So that's one example that has become big. Same with microbiomics. I talked about that. Graphene, that's an example that showed up in our top 50 selection in 2014. We've been tracking innovations in graphene, its processing, integration in other materials and application landscape for a number of years. We were one of the first to highlight the application potential of graphene in electronics and sensor domain as early as 2000, wherein we had highlighted its use for the development of sensor probes based on some research we found happening at Harvard. Now, graphene-based sensors are considered one of the highly effective sensor technologies which can provide the necessary functional benefits. And if I may add one more example, super hydrophobic coatings. As the name suggests, these are coatings that repel water. Through our close monitoring of various technologies, we had identified the growing research advances in the field of biomimetics as early as 2002, 2003. One such effect is the lotus leaf effect that was researched in the early 2000s by Wyss Institute, Fraunhofer, and MIT. It featured in our top 50 in the year 2011 till 2014, wherein we extensively tracked its growth as a technology and application landscape. So in a nutshell, I think our success rate in identifying technologies that are likely to become big in the future has been very good. And I'm very confident that, again, the list of technologies we have come up with this time, which is the 8th year, we'll see how that goes. But I feel very confident that these are some of the technologies that will make it big in the near future.
Thank you. Another question that we have is, will the presentation be available on demand? And the presentation will be available on demand about a few minutes after the presentation has concluded. So those that have joined us in the middle of the session, you can go back in and listen to the entire presentation on demand. We have time for one quick question here. 5G technology, why was that not mentioned?
It was mentioned. I think it has to be. Yeah, 5G is absolutely part of the top 50. It was part of top 50 last year, and it is very much so a part of the top 50 selection this year as well. Yeah, that's the next big thing in speeds on telecom services. It has applications on the mobility side for car-to-car, vehicle-to-vehicle communication. Certainly has big applications and benefits for healthcare industry, for robotic surgeries, and for remote patient monitoring and those kinds of applications. So yeah, 5G is absolutely going to be big this year, next year, and it is part of our top 50 technology selection.
Thank you, Rajiv. This concludes today's webinar. We hope you found today's webinar informative. If there's any additional questions or feedback, or if you'd like to contact Rajiv directly, the information is provided on your screen at this time. You can also reach him via his social media, LinkedIn, Twitter, and also the page for TechVision, as well as the video under the Attachments tab. Thank you for your time.
Thank you.